3b, balancing in acidic conditions. So most reactions don't occur in neutral conditions. If they did, it would be nice and simple, but they don't. It's if it's in water or anything like that, it's acidic or it's basic, and you have oxygen and hydrogen, and that complicates things a little bit. So there's a couple of extra steps that we need to go through when we're doing this. So the first bit is the same. You split it into two half reactions. So HClO2 and I minus 1 go to chlorine gas and HIO, hydroiodic acid. And it's in acidic conditions. So the two half reactions, if I can write, HClO2 goes to Cl2, and I minus 1 goes to HIO. Okay. Balance the atoms as you would in anything. Let's take a step back. Balance the major atoms. So what they mean by major atom is the thing that is undergoing oxidation. All right. So we're not going to worry about hydrogens and oxygens at this point. We worry about them later. So the only thing you're really going to try and balance is the chlorine here. Okay. So I have to put a 2 on the left side. Now the chlorines are balanced. In the one below it, do I have to add anything? No, because we're just trying to balance the iodines. Okay. You're only balancing at this step the things whose oxidation numbers change. Okay. That's all we're trying to balance at this point. Hydrogens and oxygens we're going to do right now. So balance the oxygens first. Okay. You do this by adding water. So we look at this reaction. How many oxygens are on the left-hand side? How many in the top equation? Sorry. 4, right? There's 4 oxygens, right? I have to have 4 oxygens added onto the right-hand side. I use waters to do that, so that means I have to add 4 water molecules. Somebody's excited. All right, so I add 4 waters. The one below it, I have 1 oxygen on the right, so I have to add 1 water on the left. Okay? Is everybody with me? Okay. Now we have to balance the hydrogens. We are in acidic solution, so we're going to balance the hydrogens by adding protons, H+. Okay? So look at the top one. We have 2 hydrogens on the left, and we have 8 on the right. So what am I going to do? Where am I going to add my protons? The right or the left? For the top one. On the left, right? And I'm going to add 6 of them. Okay. 6 protons. Now I've got 6 plus 2 is 8, and I've got 8 here. And then the bottom one, I've got 2 hydrogens on the left, and I've got 1 on the right. So I need to add 1 hydrogen or 1 proton on the right-hand side. Boom. Are we good? Okay. Now we have to balance the charges. So the top one has, what's the charge on the left side of the top one? 6. What's the charge on the right of the top one? 0, right? Nothing is charged over here. So I'm going to bring this positive 6 down to 0. How do I do that? You add 6 electrons to that side. I'm running out of room here. 6 electrons. Sorry. So we add 6 electrons. The one on the bottom, what's the charge on the left-hand side? -1. The charge on the right-hand side is +1. Which side am I adding electrons to, and how many? I'm just trying to balance the bottom one. You add 2 on the right. I'm trying to balance the charge of this reaction. This is -1. I can only do it by adding electrons. So if this is +1, I have to add 2 electrons, and that'll bring this overall charge down to -1, and it matches. It doesn't have to be neutral. It just has to match each side. Is that okay? You just have to match the sides. It does not have to be neutral. Okay? Okay, and remember, if we're adding electrons on this side for this one, the other one you're going to be adding to the other side, because the electrons, when we put them together, have to go away. Right now, they're not going to go away. So what do I have to do to make them go away? Yeah, I'm going to multiply the bottom one by 3 because I need 6 electrons here to cancel those 6 electrons there. I'm going to write this in the middle here. So I've got 6 electrons. And on the bottom, I multiply everything by 3, and I get 3 waters, 3 I minus. Everybody with me? Now you just add them together. The electrons will always cancel, or they should. So the electrons will disappear. Anything that is on opposite sides of the equation will disappear. So you can either just add them all and do it at the end, or as you're doing it, you can start to simplify. I have 6 protons on this side, the left side here. I've got 3 on this side. What happens to these 3? They will go away. How many are you left with on this side? 3. Okay? So you're going to have 3 protons. So that deals with that. What about the waters? I've got 3 waters on the left over here, 4 waters on the right over here. Which side is my water going to be on? It's going to be on the right-hand side because those 3 get wiped out and there's 1 left over here. So if I do an arrow, I've got 1 water molecule over here. Nothing else is going to cancel. So then it's just the 2 HClO2 plus the 3I minus plus the protons goes to the water plus the chlorine gas plus the 3HIO. And that is the balanced reaction. Should always check it. Two hydrogens plus 3 hydrogens is 5. 2 plus 3 is 5. 2 chlorines, 4 oxygens, 6. What? Oh yeah, 3, 4. There we go. Thank you. So it's 4 and 4 oxygens, 3I minus, 3I minus. And we did the protons already. Okay, so once you balance the atoms, you got to look at the charges as well, though. What's the net charge on this side? Thanks. 0, right? Because there's no ions on this side. What's the net charge on this side? 0, because it's 3 negative 1s, 3 positive 1s. That's a net charge of 0. So the charges are balanced as well. Okay? It's the exact same as the other stuff, except we've added in the extra step of, after you do the atoms, you balance the oxygens using waters, and then you balance the hydrogens by using protons plus H pluses. Go in that order. Don't try to balance the hydrogens first and then the waters or the oxygens, okay? Add the water first, then balance the protons. And just a couple of things. The balancing of the electrons is where a lot of people go wrong. So here, when we were trying to balance the electrons, you just have to get it to the same charge on each side. It doesn't have to be zero. Sometimes it's zero, like in this case, it was 0. 6 electrons, 6 protons gave me a net charge of 0. But this side is negative. You can never get rid of that negative. So you're adding electrons to this side to make it equal to that. Okay? It does not need to be 0, but the electrons do have to cancel out. So when you're writing these big things out, you just have to be careful with all your charges because now they really matter. In grade 11, when you were balancing reactions, it was all just about the atoms. We didn't really worry too much about the charges. I mean, you wanted to get it right, but now it actually matters. Okay? So just be careful with the charges. Basically, this is going to be practice. There's only 20 minutes left of class. You can just work on the questions on the back. I'll post the answer key. Tomorrow, we got to do basic, which has an extra one last step. I know. I told you, this is all the setup.